So the telephone just rang back again. It didn't work, so let's try with F3. Plus minus 1. And then let's take 1 plus x squared again. F of 0x, that equals 1. And f of plus minus 1x equals f of x. Then we shouldn't have 1, then we should have x plus x to the fourth. Then f of naught vanishes, and plus minus x gives f of x. Oh, it vanishes. Oh yeah, that's naught times f of x. And this is, now what was it? Lambda to the nth, that's plus minus 1 to the second. So that means that the relation here holds for all positive integers, which is not the order. So that was the counterexample. Now going back to this exercise. So we need in an infinite field to have an element where all the powers are distinct. Or that would be sufficient if there's an element whose all powers is distinct. So for all lambda, so what I would like to prove here is that if lambda to some power equals unity, that should be an m, for all lambda. Now, so if this holds for all the monomials, then lambda to n minus equals 1. or if it's a distinct guy for the distinct from zero, a non-zero value of m for all lambda, then lambda is finite. That's what it's about. And I must admit, I don't know enough about fields to handle this. So I'll have to look up some theorems on fields. Or let's just wait a while to see if I get some idea. Oh, maybe we can do it if we have if all elements are powers of lambda, then we are in a finite field. So if we have two elements, a, a and lambda, or a and b, which are not powers of each other, then we can construct something like a to the ith, b to the jth, and that's an x, and x to the mth is equals unity, and this is of course a power of unity, so that didn't give us anything. How about x equals a plus b? So we use the binomial theorem. Does that give us anything? This is going to be a very long way to work on it. This should, could we get like a minimum m for which it holds, but then may hold for an infinite number of n's to be part of it? It's very unclear thinking up till this moment. Well, let's stop here, and then I'll see if I can think of some idea.